Hello, everybody, and welcome back again. Our second section video, which is going to be about how to import an AutoCAD file into ETABS 18. In this topic, or in this type of technique, it's really important how to know to convert AutoCAD file into ETAB file because sometimes or almost you as an engineer, as a structural engineer, when we receive an architect plan, we face a lot of difficulties sometimes to read the plan layout, a lot of layers, too many layers. So we need to convert first the architect plan into structure plan. We need to focus only on the structural element like columns, beams, walls, opening, because as you know, in the architect plan, usually we see the columns location position, but the beams is our responsible. So in this session, I'm going to teach you how to convert an AutoCAD file, how to filter the AutoCAD file, how to make it simple to read the layout, structural layout from the architect plan into structural layout. So let's start. Let me share with you the file. That's fine. Put the screen. This one. Okay. So here's we open the file, the AutoCAD file. It's a residential building tower. We have I take only this layout. As you can see, there's a lot of layers here, a lot of layers, which is our and which are with different colors, and sometimes, as you see, some is messy to read this layout. So what we are going to do today is to filter this layout to see what we are going to take and what we are going to leave. So usually you can see this, for example, should be the walls or the partitions in the house or in the apartment, and here's this X symbol means there's opening here or ventilation or void. So we are now trying to read the plan layout. This one means window. Yeah, this is window. This is the doors. Okay, this is what's hatching here. This hatching, maybe the balcony outside. And so not everything in the layout we can take, not everything. So okay, here we can see, what we can see is this wall. I think this wall is for core wall. Here should be lift 1, lift 2. We have lift 1, lift 2, or we can call it elevator 1, elevator 2. So, and here's we have the staircase with opening. Okay, now I'm trying to read. Here's the doors. So maybe it's this is split. This is splitted into two apartment, left and right, maybe. So, but the important thing here that I'm going to tell is that we need to filter. We need to remove something that we don't need. How we can do this first? Okay, let's filter first. Okay, this one, this bubbles, no need to look about it. We need to select only. We need to select only. Please concentrate with me. Only the structural element. We need to concentrate on the structural element, like walls, like columns. Here's I see columns. There's a lot of columns here. There's a wall. Okay, we have columns and wall now. We have voids. Don't forget the voids. We need also to make a slab of the structure element of the building. So let's start. Let's start one by one. The first step is to to start with the layout of the slab. Okay, so start with the layout of the slab. We need to define layer. As you know, we are working about ETABS. ETABS is a layer, slab layer. So let's define layer. Define number one here. Okay, I will define this. Sorry, ETABS slab. Okay, I will change this color. Let's take it, for example, green. Okay, we take it to green. So we define the first layer, which is ETABS slab for this apartment. So how we can define this layer on this AutoCAD file? First, you can start with a polyline, the polyline which have starting point and ending point. Okay. For example, not for example, we can start with from this joint and go through the slab. Okay, we can go through the slab till here. This one just start. Okay, I want to manage this here. This here. Through the columns. Forget about the doors, forget about all these things, just focus on the boundaries of the building or of the slab. Okay, you continue this polyline. Be careful, don't miss any part of this building. Take this here. Take this here. So the most important thing is to take every single part. Sometimes there are partitions, like yes, we have these doors, we have this curvy balcony, yellow balcony curvy. We can ignore this. Ignore it because this is like a decoration. It will not affect the structural assessment or the structural analysis of the building. So let's continue. Let's continue until here. Okay, let me take this part. This part. Okay, let me take this part. This part. Okay, until we close it. So we can see now we have, if you click on it, this one the green color, this one our building parameter. So to show it clearly, press this one, go to layer isolate, you can see this is the green part, okay, this is let me control C, control, okay, this is the slab. So now you can see this is the slab of our residential tower building. So the first layer have been done. Just I make copy outside just to show you. Okay, let me make another layer and isolate. Still have this one. So the first step is ETABS slab. The second step is how is about let me draw the columns, the vertical element. This vertical element you can see here. Okay, it is already done by the architect, but for me I need to double check because sometimes for example this column is not connected together, the four lines. If I make explode, you explode now. See, it have 1, 2, 3, and the edge here 4. So it's important when you are doing the AutoCAD file to convert from AutoCAD to ETABS, you need the full element to be closed like this one. Starting end is here, start and end point is here. So it should be like this. When you click on the column, it's be connected. So for double check, you need to go one by one through the columns and define it. So we need to define a new layer, add a new layer, name it the same family name, ETABS columns. Okay. Change the color. Let's change this one to blue. Okay, blue. And close. So go to ETABS column. Okay, this one. Again, go to the rectangular option and go one by one. One by one. And make sure it is closed. See? Press enter again. One by one. You need to be careful. Don't forget or don't miss any column in the layout. So now we are trying to organize our file. We are trying to filter the AutoCAD file. That architect layout, as you see, is very messy. So you need to go one by one. Column number 1, 2, 3, 4. So if you some students now asking themselves why doctor is not making isolate directly. I can make isolate directly for the columns, but as I say, I'm not sure that each column is like a one box connected. So without any errors, just do it. And another thing, if you can see that the architect defined this wall, he defined this wall as a columns. So for our as a structural engineers, we should know the difference between structure, between columns and shear walls or core walls. So I cannot everything follow the architect. Here's another column. So I will skip this. Because for me it is not a column. The column is something else for us. Okay. And this one I will not consider it as a column. I will consider this one. I will consider this one. I will consider this one. Okay, we still have more. I know sometimes it's look boring to do it, but I make it slowly just to make sure I don't want to make any mistake. Okay, you see a lot of hatching, numbering. Okay, here's the stairs. Column. Okay. Okay. I'll take this. I'll consider this wall like this one. I'll consider it a wall, yeah. Let's consider this one as a column. This one. Okay. So see the problem that he defined columns and walls as if are the same element, which is not true for us. As a structural engineer, you may always have your own decision and your own opinion that always architects and the structure have conflict about the position of the columns and the size, so on. So let's continue here. See, I make a mistake here. I need to redraw again and go one by one. So we have this one. We have this one. We're almost near to finish the columns. There are too many. There are too many columns. Try to finish them all. And go step by step. So this could happen when the architect put the columns and the wall as the same layer. This is a big mistake. So that's why you need to read and to focus. See this one. See, we have also here a mistake to be revised. See the columns outside and the slab is inside. But it can be fixed inside ETABS. Okay, so we have done the columns. We have done the columns, and I need to fix this for the slab. Just move this to here, and that's it. See, that's it. So we have we defined. Now I want to remove this because we have changed it. We have done. Let me get the slab first. Layer isolate this one because I have changed the size, or I stretch the slab just to make copy, put it on this side. Okay, layer and isolate. Similarly for the columns, you should make layer isolate. You should isolate the layer. See, we have isolate all the layer. Just take this one. I take this copy, all the columns together, and go and put it on the corner so to overlap. So now you can see we define the slab, and we know the columns. So now it looks better and nicer to see it and visualize the building and the layout in a simple way. See the comparing between this one and this one. This is the architect plane layout. He put everything: windows, walls, partitions, corridors, decoration. And as an engineer, as a structural engineer, you need to convert all of this into structural element. What is a structural element? It's the vertical element, which is the columns. It is the horizontal element, which is the slab. It's the horizontal element, which is the beam, which is the vertical element, which is the walls. So in this scenario, or in this case, we can see there's the architect want to make it a flat slab. Maybe he want to make it a slab, and maybe we can make it as a with a frame, or we can make it with we can insert the beams, so it not be flat slab. So we will decide this later on. We can make two samples, one with beam, one without beam, to know how to insert this file into ETABS. So let's go back to the architect plan layout. Layer and isolate. So we have done the slab, we have done the columns. Now generally the architect engineers, they don't put beams. They leave the decision for us. So as a structural engineer, based on the slab, based on the span between columns, the distance, how it is economy for us, how the thickness of the slab is, how the reinforced material are distributed. So based on the economical and economical wise, and the safety also, you should combine the safety and the economy when you are going to make a project. So in this project, I will make two samples, one with beams and one without beams. So just to let you know, to teach you how the ETABS define the beams. Okay, how the ETAB can read the beam as a frame element, or as a shell element, or as any object. We will see. So we need now to go to the third structural element. We have done column, we have done the slab. Now we are going to make the walls, which is not defined by the architect engineer. So go to the layer and define a new layer. See, doesn't matter, you need to follow what the architect is adding in his layer. Just put your touch. ETABS/walls. I will add this one. ETABS/walls. I will add just a color, change the color. Let me change it to red. Okay, red. Okay, red, and that's it. So search for the ETABS wall. Oh, we have ETABS wall. So again, the ETABS wall, we have two types of definition, or two types of two types that the ETABS can read the walls. He can read the walls as a shell element like this, connected, and he can read it as a line or frame element. We will see. So again, the same concept of the column will be applied on the wall. So bring the polyline. See, if I want to do this, it is fully connected. Make it explode. And now it is, see, we have different part here. So you need to go to ETABS wall, click on polyline, and start connecting the element together. Okay. Okay. Continue. this wall. This wall. This one. Okay. And close here. Okay, this for wall number one. Wall number one. And now we are going to see other walls in the building. Okay, we have this wall also. Can click as a rectangular shape here. Rectangular. And close this. What else? Is there any walls here? Too many colors. Okay, this is column. Yeah, they have one wall here also. Okay, this one. One, two. Yeah, we have another wall here. Connected. Okay. So yeah, we have done the walls. We have done the walls. And let's make it isolation again. Layer isolate. No. Button. Okay. Click on this. ETABS Wall and press and layer isolate. And then just select Ctrl C or CO and try to move from the edge so everything will be symmetric or overlapping together. Now we have seen the slab edge, which is a green one. We have the columns. We have a core wall here. We have 3 shear wall. So layer and isolate again. So what else? What else? Okay. We have done the slab. We have done the shear walls. We have done the core wall and the columns. What else? We have the opening. This opening, the X opening, means there's a void or means there's a ventilation. So this ventilation means the slab there's no slab here, means there are no rebars, no concrete, no reinforcing. So this is an empty part. So this empty part should be considered in the slab. So please take into consideration the voids because around the voids they have a specific design. Usually we put 2 rebars here up and down. We put 2 rebars here up and down, 2 rebars here up and down because usually in this area, in the corner are the edges, in these edges, the crack could happen. So we always go to reinforce the edge of the opening. So we need to define also another layer. Name it add ETABS. I will name it opening. Can be opening. Opening. Okay, let's keep it opening. Which color to use this for? This one. Let me use the cyan. Yeah, cyan, light blue. Okay. Okay, let me take a drink water. Or we continue. Okay, so now we define the slab, the column, the wall. Now it's time to go to the opening. So how to define the opening? The same thing. Click on the layer, ETABS opening, this one, and you can make it as a polyline or like a box. Let me take this one. You can see the opening is here. So in this case, we should go to polyline. This one, this one, and let me combine all the opening together. Or let me take this open alone and this open alone. Okay. So this is the first opening here. And let me take the second opening for this area. So in this way, you know where the location of each element and clearly to read the map. It's really clearly to read the map. And close here. So we have this opening number 1, void or opening number 2. What else? See, it seems like symmetry. If you this part and this part, as if it's a symmetry. So I will make it for this one also. Polyline 1. Okay. Okay, done. This also for void number 2. This one like this one, and this one now should be finished. So now we define the voids and this in this 2 area. Let's see what words else. Of course, in the lift. See the architect here. He named hatch bath slab for him, but for us is different. He put COLL. What does that mean? COLL. No, this area should be void. This area because there's a lift or elevator. Of course, the elevator will not considered as a structural element, but inside the elevator, it is a void. There's an opening, so there's a hole in the slab. So we should remove this hole. Okay. So the void usually will start from the edge to the edge of the core wall or the shear wall. So still in the same definition, ETABS opening, go to this one. I will make it fully closed. Okay, this opening, I will do this one. Okay, so we have 2 voids here. Also, if you see besides the elevator, we have the staircase. This is the staircase. Around the staircase, there is an opening here. Inside the staircase, there will be an opening. See how the architect see this one is a column in the definition, was a column in the definition of the architect. But in our case, as a structural engineer, this one is a shear wall because we need to connect. This is 3 steps of stairs between the wall and the other wall. It cannot be a column in this side unless if you want to split, if for example, if I want to split this wall into 2 columns, I can put this one here. Okay, consider this one here. I will consider this one here. This can be another type of design if the architect accept. Okay, but I agree, and no problem to keep the wall instead of 2 columns. As a high-rise building, a shear walls is needed, or not high-rise. It's maybe consider 10 stories towers is considered a high-rise building. So we have an opening here. Go to the layer again and close this one. So we have opening here, opening here, opening here. This X is good. I think I should put the X. So to know the opening layer for us. Okay, this X. Also for here. So see here, I found a mistake. I want to, okay, make it changes here. And I think here, so it's very critical to focus when you are drawing. So this is the opening number 1. Let me see, is there any error here? No error. Great. Continue. Draw the X. So another line. And that's it. So I'm going to do this for this two. For this two, change it to ETABS opening. I change it and change this one to ETABS opening. Okay. So we have 2 opening. Okay, for this one and this one. We still have this one, this small one, even small. Just don't miss any element in the slab. Okay, this one, back to the line. Let's change this line to ETABS opening. Okay, and go for this line for ETABS opening and consider this opening here. Right? True? Correct? Just let me check if I connect this one. This one. That's on also. Okay. Okay, it is linked together. Great. So we have done this one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 openings. And so now what else we have? Yeah. We have this one. We have this one else. And we have this one here. There's also an opening here. Okay. Let me remove these dimensions just to clear it. Later I can see this. Okay. Opening here. No, you see, because there's a column inside, I cannot do it a box. I need to make it a polyline. And connect change this one, and change this one to X, and to this X. Just like I want to see the sample of X. And we have another opening here. Change this. See, doing the DXF, the drawing file is the most important part. If you do it correctly, you will not face any problem during the modeling stage. Just know every step. So we have this one. We still have one more. Yeah. We have one more in the middle. This one in the polyline. Okay. So we change this to so we have done the opening. Is there any other opening here? No, finish. Okay, now we need to isolate the layer as we have done before. Layer isolate, press on this lighter blue, press enter. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 openings. Select all, CO copy. And the copy, I'm taking this origin column and move it to the slab. Layer and isolate. Okay, so now we have the fully slab for the ETABS modeling. This is a DXF file, the DWG file. So let's see what else we can do after taking into consideration every single element in this stage. Remember when I say the column, or sorry, the walls have two different type of definitions in the modeling. You need to define, to draw a line from the CG to the CG. What I mean by CG? Okay, let me draw this line like this. Okay, I want to know the thickness first of this wall. What is the thickness? It is 25 centimeter, which is 0.25 meter. So this one, just we need to know the thickness of the wall, and the thickness of this wall also same. And let me see the thickness from this side, also 25. So we know now the thickness is 25 centimeter. So I need to draw a line from here to here. Okay, draw another line from here to here, and CO, enter by 0.125. I go to the mid 0.125. Okay, I will go to make mirror. This one. I have the mirror. I want to trim this one, trim this one, and trim this one, trim this one, and I need to trim and trim here. So, and remove this one. So we have 1, 2, 3. Change it to wall. So ETABS sometimes can read the shell element, and he can read this line element. So I prefer to make both, but make sure don't duplicate during the model. And for this one also, we forget this one. Okay. This one for the boards. So now we have the wall. We need to know the columns. Okay, I isolate columns. I need to isolate here. Okay, so press properties. We have 85 columns. I did this to know how many columns we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23, 24, 25, 26, 27, 28, 85. 85 divided by 4. So just want to know what is the sections. There and isolate. So the section for this column is 30 by 70. 9.9. 9. We should be careful during modeling. 10.9. So this. So let me remove this. I want to fix this to be. See, we need to fix this. We need to fix this to be. Okay, take this one and move. See, sometimes architect, I will move this to here. To order center back. I hope now it is fixed. Now it is fixed. See, sometimes the architect did mistakes, but we need to check each section alone. 170, 130. So we have 30, 70, 30, 70. I think what else says here's a different size. We have, yes, we have different size. I think here we have 130, we have 30. So we have different size of columns. 90. Later on, we need to double check the capacity, of course. Design check capacity 30, 30. This one, 29%, it's a mistake here. This one, 70. So the same mistake. It's here, take this one. CO, CO, copy, and move to here. Click on it, draw order, send to back, and delete the old one, and check the size, 30. And 70. So correct, this one correct. This one 30, 90, 30, 90. Okay. This one is same. See. This one is 100.049. So it need to be 100. So we need this one to be replicated and rotated. CO, this one to here, RO, rotate. Okay, move this one. Move this one to here. So move. Okay, throw order, send to back, and delete. Now it should be fixed. Okay, now it's fixed. So sometimes you need to do double check. So that's why I say that AutoCAD is really important in the first stage of drawing and modeling. Not anyone, as I say in the first session, ETABS is not like a video game, just click, and you see the building model. No. See, here's a mistake also. Here's a mistake. This mistake need to be fixed. I think I remember this one, the same section. CO, copy. Okay, copy, CO, paste it here. Send to back. And now we need to double check again. Okay. Okay, good. So similarly for this, 80, this one 30. We have the same problem. Without filtering the map, you will not see these errors. You will not see this error. Draw order, send to back. True. So we go to this one, and we go to this one. 80, true. Oh, this one is good. Correct. Okay. On this side, okay. You have different section. You have 80-30, we have 90-30, we have 70-30, we have 130-30, we have 110-40. We have most of the thickness is 30 centimeter. So maybe because the walls, but the partitions use the thickness. continue and be full focus. Okay. Okay. So this one is checked. This one. We need to check one by one. See, here's another mistake. Okay, 30, 70, we have take this one. Take this one. It's okay. Draw order. Send to back. Delete. And check the dimension again. Done. Okay. Okay, great. See, there's could be a mistake. 79.99, which is 80. This one 30. We can see this one. I see the building. This one 80, 30. Copy, copy, and paste it. I forget which one. Let me see. Maybe this one. Okay, this one. So move this one. Replace it here. Also order. Send to back. And remove. So now this one's 80. Similarly for this. Okay. We're almost near to finish the double checking. 110.1.1.1. Why? It's okay. Go to this one. So I want to see the thickness. The thickness is 30. So we need to make it. I will try to make it this one, like this one. Should be symmetry. Because 110, 40. I'm going to make it the same. 110, 40. Let's take this one. Oh, this can be a mirror here. Or maybe you see 30. It has a purpose here to connect these together. So, okay, no problem. Go to ETABS. On. 150. I see. See? I need this all to be connected. So now 150 is connected, and we have 30. Have another. There's a lot of mistakes here. 110, 110, 110 is 30. Have this one. Take it and replace here, just to make it faster. I know this takes a long process to finish, but we cannot move on. We cannot move on without this process. Okay, see now. Okay. So let me see, is there any mistake here? 70. 70. No, this one is correct. Yeah, take this one too. Okay, so this one is correct. We are doing our best to make everything exactly correct. Our work should be precise and accurate as a modeler, as a designer, as an analyzer. So okay, so 70, 30. So almost. So let's go. Okay, most of the columns are correct. Most of them now, 99.99 is correct. So if we go to this one. So now we need to see the wall section. Design. See this one 30. This one 30. And this one is 30 point something. Never mind. Let's fix this. ETABS Wall. Draw a line here. B down 2.3. Now we can close. Now we can close Moses. So we have this line. See? Center back. Remove this one and remove this one. And remember, still we have. So now we have this plan view with the columns, with the walls, with the opening, with the flat slab. So what we need to do now, remove this. Okay. After we have fixed everything, need to remove. Okay. This. Okay. And so now we have done the layout. We have columns, we have walls, we have slab. So now we can save this one as a DXF file. When you finish, I will save it as save as a drawing. Then I will save as the desktop. Change this one to DXF 2007. Okay, and save on your desktop. So now we take a break for a while and I will return back to you soon. Okay, now we'll come back again. We recently finished the DXF file for the following architect plan, and this one becomes structural plan layout, and we consider this as a typical stories. You know, in the building we have typical stories. We have the ground floor story, maybe the layout will be different. We have basement, we have roof, so the layout may be changed. So we are going to make try to make another 2 or 3 structure plan layout for the ground floor, for the basement, and for the roof. So this one is the typical stories. Now let's assume to make a basement level first. Start with the basement level. So for the basement level, we'll consider, I'll make a new layer. Okay, and add a new layer. I will consider this is basement boundaries. Okay. Boundaries. What's wrong? Boundaries. Okay. Basement boundaries. We'll change the color to maybe grayscale. Okay, gray. And let's try to take the slab or the boundary level for the basement is this one, starting from here. And if you consider this as here, okay. So we consider this as a boundary level, and let's make isolation for for the columns, for the boundaries, for the opening, for the wall, and that's it. Copy and go to this level. Okay, so now we have the basement level. This is the boundary considered like as a foundation or raft foundation here. We just, of course, in the raft or in the basement will be no opening. So we are going to remove also again layer isolate and delete the layer, the voids, and layer and isolate again. Okay, so we have this. So we have this foundation. We have the walls, we have the columns. Usually in the foundation as we will have here like a retaining wall. Retaining wall for the fill, usually the fill, if the fill come from this side. Let me show you. If I draw from this side, usually will be like a soil. Okay, soil in this direction at below the street level is pushing, having a pressure. We say it as a constant pressure P0 or PA on the retaining wall. Okay, so we need to draw here a retaining wall in the basement level. Okay, let's draw this again. Okay, so the retaining wall it will be the same as we consider the same as ETABS walls. I will consider this like we can consider. Let's take the same thickness here. The thickness here is 30 centimeter. So we'll take here 30 centimeter. 3, sorry, yeah, or so 0.3, and go to here. Okay, go to here, trim, and you will have I think the wall should be, we have okay, okay, spacing here. Spacing is correct. So you can consider this wall is here. 0.3 and so on. So we have this together and draw the wall. Okay, draw order, center back, remove thing here. So we have draw the first wall here and draw, sorry, and draw this one here. And draw to this one, draw to this one, draw to this one, and draw this one. Okay, export all. Okay, TR and XT. Okay. I need to trim here, trim here, trim here, here, and trim here also. So we have the wall now. Try the wall again. Okay, let's throw the wall here. Just to close this. And close this side. Okay. And close this side. So we have the retaining wall from this side. And let me draw the line here for the modeling. Okay. Draw a line here and draw a line here. So now we prepare the retaining wall from this side for the, let's name this as a okay, ground floor level. Oh, sorry, basement. So we have the basement level. We have the typical stories. Let's move this here. Okay. So we have the basement level. We have, okay. So now we need to do the ground floor level. Okay. Make the ground floor level is this all 0 and go down. So we need to draw the ground floor level, which will be ETABS slab. We'll take the wall, this one. That's our margin for the GF. We'll still have the voids. So this will be the ground floor level. So we have the basement, ground floor, and typical stories. So now we have done all of these. And we may also have another option, which is a roof story. Maybe we can draw a roof story here. And the roof story. Take this, copy, and move down. Okay. So in the roof story, we'll have a slab here. Let's take this one until this one. Okay. So this will be the roof stories. We can remove all these. We can remove all of these. We can remove all of these, and we can remove all of these. So this will be the roof level. Okay, so we have basement, typical story, ground floor level, and roof level. Just save this. Desktop as a as TXF. Yes. So we have this four layout. So now we have prepared all the layout, and we need to take each one into different file as a DXF. I will share this with you here now. Share. Let's go to DXF. And this one. And this one. Share. Screen. Okay. So we go to AutoCAD files here. So here we have the basement level, ground floor level, the roof level, and typical story level. We go one by one. This is the basement level. Let me remove this because we need it only an AutoCAD file. It's at the XF. Basement level, save override. Yeah. Okay. And you can see here the roof level. You can remove the roof level, also this one. File, save as the XF, overwrite. Okay, replace it. And we go now for the typical stories. Remove this. File, save as the XF. All right. And now I have done the basement, ground floor, I've done the ground floor, and the ground floor level. Moses, file, save as, and accept. So we have done all the files, ground floor, typical stories, roof level, basement level, and all the residential building here. So the next stage is how to import these AutoCAD files into ETABS. We go for ETABS 18. Okay, we go to make a new model. Metric, as we said before, ACI. Okay, we need to make it irregular for sure. If we have 10 typical stories and one roof and one ground floor, and the basement, so we have 10, 11 for the ground level, 12, say 12. We have the typical story height will be 3.5 meter height, and the bottom story height will be 3.2, or should be higher, make it 4. Edit story level. We have this one, the ground floor level, first story, second story, third story, fourth story, fifth story, 6, 7, and the roof. So we have the total height is 42.5 meters. Okay, so we use the blank, no grid here, because the grid option is different than importing AutoCAD files. Okay. So this is Windows open, ETABS, go to File, Import. We have DXF Architect Grid. We have DXF Architect Plan. We are working about DXF Architect Plan. Go to AutoCAD files. We have basement level. We have the ground floor level. We have roof level. So the basement level, this is the basement level, and this is the ground floor level. So if you want to go to the basement level, you get meter, go to the ground floor, and it should be in meter. We cannot open it. Why? Because we should close all this. Close all this now. And now try again, File, Import, Architect Plan, basement level, in meter, ground floor level. See? We have here the ground floor level. Everything you need is now here. Here's all. You can see the basement level from here. Why I put it in the ground floor level? Because I want the walls to go down, and this one will be the ground floor. So if from up to down, the wall, if you draw a wall, it will go down to we are standing now on the ground floor. Okay, imagine this is the ground floor. I want to draw the walls here and the columns. I need them to go down. So when I draw from ground floor to the lower level, it will go down. This one is empty now because we're not drawing yet. So this is the way how to import the AutoCAD file into the ETABS. And if you want to go to option to see the architect plan option, what you need from here is ETABS lab. We need ETABS lab. We can take all these. Okay, remove all these. We need ETABS lab, need ETAB column, ETAB walls, ETAB opening, and basement boundaries. I can remove the basement boundaries. The gray color will remove. See, no basement boundaries. If I want to remove the columns, go AutoCAD plan and remove. Still have this. If I want to remove the columns, just tick one, and your columns will be removed. You see the walls only. So this is the way how to import the AutoCAD files into ETABS. Thank you so much, and see you in the next video.